Hello everyone, welcome to EDUSOFT. This is our fourth session. We have already completed some image operations like copy, paste, rotating an image. In this session, what we will going to learn, we will going to see how we can detect image edges, creating border around an images, blurring an image. Coming to first one, that is border around an image. cv2.copyMakeBorder method is used to create a border around the image. So if I want to create a border around an image, what method of OpenCV we are going to use? We have to use copyMakeBorder method of OpenCV. So you can see a syntax over here. Import cv2 as mycv. Import pyplot from matplot library as plt. After this is the image reference path and we are using imread method of OpenCV. After this, you can see over here, image equal to myCV copy make border. So this is the method and in this first argument is the image reference path. The second argument is the width of the border, that is left, right, top and bottom. After this, myCV dot border constant. Here border type can be any like border constant, border default and border replicate. What border type we are using over here? We are using border constant. After this none and after this value. We are giving value equal to 0 so that the color of our border will be black. So value indicates the color of your border. We already know this thing that OpenCV always follows BGR color model. So if you want to have another color or any other color, you have to give the value of BGR, that is blue, green and red. After this plt.im show, within this argument is image reference and this plt.show. You can see your output like this. So this is the image and you can see a black border around the image. So if you want to have a border around the image, what method of OpenCV you have to use? You have to use copyMakeBorder method of OpenCV. Coming to next one, that is blurring an image. Image blurring refers to making the images less clear. You can see a syntax over here. Same, import cv2 from matplot library, import pyplot as plt. After this, you have to give the image reference path in imread method of OpenCV. After this, image equal to mycv.Gaussian blur over here. So there are many algorithms in OpenCV that you can use to blur your image. What algorithm I am going to use over here? We are going to use Gaussian blur algorithm of OpenCV. In this, as an argument, as the first argument, you have to give the image reference. And the second argument, you have to give the parameters till what and till where you want to blur your image. After this, mycv.im show. First argument is the Gaussian blur and the second argument is the image reference. plt.im show image and then plt.show. You can see your output like this. So this is the output image. This is the blurred image of an actual image. So by using the different algorithms that are available in OpenCV, you can blur your image to the desired rate you want to blur your image. Coming to next one, that is edge detection. So this is the syntax that you can use to detect the edges of any image. Import cv2, import numpy, import matplot. After this, you have to give the image reference path. After this, here we are changing the color code, that is BGR to RGB after this. So in edge detection process of OpenCV, OpenCV has many algorithms we can use. What we are using over here, we are using Kenny edge detection algorithm of OpenCV to detect the edges of our image. The first argument in this is the image color. The second argument is the threshold and the third argument is threshold. So by thresholding, we reduce the amount of high frequency content like noise, which makes it easier to identify the predominant edges within an image. There are many algorithms which you can use. After this, you have to define the subplots by using PLT library. After this, you have to show your image as an output as the original image and the image edges, that is the output image. After this, you have to transfer inside axis, and after this, you have to show the output like plt.titleAout and plt.show. And you can see over here, and you can see the output like this. This is the original image, and this is the image edges. You can see the edges of an image very clearly over here in an output. So by using different algorithms available in Opencv, you can detect the edges of any image you want to detect. Here in this syntax, what algorithm we have used? We have used Kenny edge detection algorithm. So this is all. Now coming to Jupyter Notebook, there we are going to see all the functions and methods we have seen till now. Number one is border around an image. So before starting, what we have to do, we have to import CV2 as my CV. After this, what we have to do, we have to import pyplot from matplot library. That is matplot library. What we have to import, we have to import pyplot, and I'm going to import this as PL. After this, what we have to do, we have to get the image reference path. That is image equal to my cv dot imread method of OpenCV. And in this, we have to give the image reference path like this. After this, what we have to do, we have to create a border around an image. So we have to use copy make border method of OpenCV. So my cv dot and copy, that is copy make, and after this border. So this is the method we are going to use to create a border around an image, copy make border. In this, what we have to pass is the first argument as the image reference, and second argument is the width of the image, and third argument also, that is the left, right, and then top, and then bottom. After this, what we have to do, we have to give the border type. I'm going to give border type as my cv dot border, and I'm going to use the type border constant like this. After this, what you have to give, you have to give the none value, that is the none argument like this. And after this, we have to give the value. And in this is the color of your border. I'm going to give this as 0. And after this, what we have to do, we have to use matplot library like plt.imshow. Within this, you have to give the image reference, and after this, plt.show. So this is the syntax to create a border around an image, and you can see your output like this. So this is the output image, and you can see a border, that is the black border around an image. In this way, you can create a border around an image by using copy make border method of OpenCV. So in the place of this black colored border, if you want to have another color, what if I want to have a red colored border around my image? So what we have to give? We know that OpenCV always follow BGR color model or RGB color model. So if I want to give the value of RGB, that is red, green and blue, so you can see your output like this. Here, what you have to give, you have to give 255, 0, 0. So this is RGB. That is the value of red is 255 by placing all the other values, that is green and blue as 0. And you can see your output as this. So this is the red colored border. In this way, you can create a border around an image, or you can change the color of your border around an image. Now, coming to next one, that is blurring an image. So what we have to do, we have to create a variable named image. And here we can see we have different algorithms in OpenCV to blur our image. What algorithm we are going to use? We are going to use Gaussian blur algorithm of OpenCV. So like this, what we have to give in this as an argument, we have to pass the image reference as an argument, and after this we have to give the parameters to blur our image. And after this, what we have to do, we have to write my CV dot, and I am show within this as an argument. What we have to give, we have to give Gaussian blurring as an argument as the name, like this Gaussian, and after this blurring. And after this, what we have to give as the second argument, we have to give the image reference as a second argument. After this, plt dot I am show within this as an argument, you have to pass the image reference. And after this, we have to write plt dot show. So this is the syntax you have to use to blur your image, and you can see your output image like this. So this is the blurred image. You can see over here, this is the blurred image. In this way, you can blur your image by using Gaussian blur or other algorithms of Opencv. Now coming to next one, that is edge detection. So for this, what we have to do? First of all, we have to change the color code of an image. So write image color equal to my CV dot, and I want to change the color like CVT color we are using, we are using CVT color method of Opencv. In this, we have to pass the first argument as the image reference, and second argument is the color from BGR to RGB. So we have to write color, and we are changing this color from BGR to RGB. Now in this, after this, what we have to do? We have to use different algorithms to detect the edges of our image. So Opencv have many algorithms. What algorithm I am going to use over here? We are going to use Kenny algorithm over here. So you have to write mycv.kenny. Within this, what you have to give as the first argument, you have to give the image color reference variable as the first argument, like this. After this, what you have to do? Like this, color. And after this, what you have to do, you have to give some threshold limit. So your threshold one limit will be 100, and you have to give another threshold limit, like threshold 2 limit as 100, or we have to write as 700 over here, like this. And after this, what you have to do? You have to create some subplots. For this, you have to write like this, or you have to use the matplot library plt and its method subplot. So you have to use subplot method of plt library or matplot library. In this, you have to give the arguments like this, and after this, you have to give the fig size equal to, in this, you have to write 7,4. So this is the argument you have to give to create the subplots by using matplot library. After this, what you have to do? You have to set some coordinates. You have to set some coordinates for your input image and for your output image. So for my input image, what is my input image? My input image is image and ish color. And what is my output image? I have to set coordinates for that also, or index for that also. So dot I am show, and within this I have to give like edge image, right? Like this. After this, what we have to do? We have to transverse inside this axis, like for x in, axis, what you have to give? We have to write ax dot set. We have to set some coordinates over here. So we are going to set some x coordinates over here like this. And within this, you have to set some y coordinates over here. You can see like this. So your y coordinates like ax dot set and y, and same like this. Like this. After this, what you have to do? After this, you have to show your output, and you if you want to show your output, what syntax you have to pass? You have to pass plt dot layout syntax, and after this, what you have to give? Plt dot show, like this. So this is the syntax by which you can detect the edges of your image by using Kenny edge detection algorithm of Opencv, and you can see the output like this. So this is the original image and this is the edge detected image. You can see clearly, you can see all the edges of this image over here. So in this way, you can detect edges by using different algorithm. In this syntax, we have used Kenny edge detection algorithm. So this is all for today. If you have any doubt, you can ask me. Today we have completed all these sessions of Opencv. Before this, we have completed all these sessions or all the playlist of NumPy library of Python, Pandas, and now Opencv. So if you have any doubt in all other sessions, you can ask me. Please give us your feedback. Don't forget to like and subscribe. Thank you so much.